Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore and Bettis family legacy of building the great state of Idaho. By the Idaho National Laboratory, mentoring talent and finding solutions for energy and security challenges. By the Friends of Idaho Public Television, and by the Corporation for Public Broadcasting.
Planets that orbit around stars outside our solar system are called exoplanets. Astrophysicists search the universe for exoplanets. But how? And is there life out there? We'll find out. Science Trek is next. Hi, I'm Joan Cartan-Hansen, and welcome to Science Trek, and welcome to the Faulkner Planetarium at the Herrett Center for Arts and Science at the College of Southern Idaho in Twin Falls. Now, scientists are standing by at the Jet Propulsion Laboratory in Pasadena, California, to answer your questions about exoplanets. And later on, we'll visit a couple of labs where scientists are looking for exoplanets and learn how exoplanets get their names. But first, let's learn a little bit more about exoplanets. A planet is a large body orbiting a star, like our own sun. There are 8 planets and 5 dwarf planets, including Pluto, in our solar system. Our Earth is the 3rd planet from the sun. But what lies beyond our solar system? Are there other planets out there? And if there are, is there life on any of those planets? Planets that orbit around stars outside our solar system are called exoplanets, or extrasolar planets. Scientists found the first exoplanet that orbited a Sun-like star in 1995. That planet was named 51 Pegasus. Since then, they have found thousands more. Scientists now think planets may orbit around almost every star in the night sky. But finding exoplanets isn't easy. Planets are very small compared to the stars they orbit. For example, the Earth is 10 billion times fainter than the Sun. So scientists use lots of tools to look for exoplanets: computers, telescopes on the ground, and telescopes in space. Some exoplanet scientists look for very slight changes in the brightness of stars. A star's light dims slightly when a planet passes in front of it. Astronomers measure these tiny wobbles of the light from a star against stars in the background to find a planet. Others use special telescopes that block out the light from a central star and take pictures looking for planets. And using special tools, scientists are discovering what kind of elements are found on these exoplanets. They're looking for things like water. Scientists think that 1 in 10 sun-like stars have Earth-sized planets that orbit in a zone where life could exist. That area is called the habitable zone. It's called that because, like Earth, it's not too close to the star, which would make it too hot for life, or not too far away from the sun, which would make it too cold. One exoplanet, Gliese 581g, is about 20 light-years away from Earth. Its orbit around its sun is in the habitable zone. Scientists are also very interested in looking at the atmosphere of exoplanets. Earth's atmosphere has things like oxygen, water vapor, and methane. Those things are there because plants create oxygen, large bodies of water give off water vapor, and cows and other livestock fart and burp methane. Knowing what's in an atmosphere can be an indication of what life can be found on the planet. And some scientists are even looking in places where planets are just forming. It's all a lot of work. There could be billions of Earth-sized planets in our galaxy alone, so the search is on. And joining me now to answer your questions about exoplanets are Nick Siegler, an astrophysicist and the chief technologist for NASA's Exoplanet Exploration Program at the Jet Propulsion Lab, and Tiffany Meshkat, an astrophysicist and postdoctoral scholar in the Exoplanetary Science Initiative at the Jet Propulsion Lab. Thank you both for joining us.
Thanks for having us.
We're looking forward to it.
Okay, let's go to your questions.
Hi, my name is Emmett, and I go to Dalton Elementary, and my question is, what is an exoplanet?
All right, so an exoplanet is simply a planet that orbits another star. In our own solar system, we have 8 planets, and they all orbit around our sun. You can imagine we have exactly the same thing across the galaxy, where all the other stars and all the other suns have their own planetary system. So those planets outside of our solar system orbiting other stars, we call them exoplanets.
Hi, my name is Alec. Is there life on other planets?
We have been looking for life on other planets, and so far we haven't found any signatures. We are still looking for the signatures of life. The things that we're looking for are signatures of oxygen in the atmosphere of these planets or other life indicators. There are also other ways to search for life, like looking for the faint radio signals that the life might use to communicate with each other, much like we listen to the radio for music.
Some of you may have watched the movie Contact, and in that movie, aliens actually made contact with us, and we love that to happen, but we're not going to count on it. So NASA and the scientists are looking for devices to probe the atmospheres of these exoplanets, looking for gases very similar to gases on our home planet, things like carbon dioxide, oxygen, water vapor, and then we can piece together the story. Do we think life can possibly exist on these exoplanets?
My name is Maddie, and my question is, how many exoplanets are there?
Well, to date, we have discovered over 3,000 planets. I invite all of you to come to the Exoplanets website so you can get a counter that tells you how many we have discovered on a daily basis. But more importantly, we believe that the galaxy is absolutely teeming with planets. We have 8 planets in our own solar system. There are hundreds of billions of stars, and what we believe is each one of these stars has probably a planetary system of their own. So there could be hundreds of billions of these exoplanets. And I think that's why Tiffany and I feel so strongly that even though we haven't yet found life, there's so many planets out there. How could there not be another planet just like the Earth somewhere else?
Hi, my name is Wyatt, and my question is, how big does the star have to be for the planet to orbit around it?
So it turns out that planets can orbit around many different ranges of stars. You might think that our sun, is very large, but in fact, it's pretty average compared to all the stars in the galaxy. What we've found is that planets orbit the very smallest stars and the very largest stars. It seems like there are planets just about around every star.
The bright light from a star makes it pretty hard to see an exoplanet, but scientists are working on some pretty interesting ways to block starlight. In this crazy engineering video short from NASA's Jet Propulsion Lab, we learn about 2 technologies used to find exoplanets: starshade and chronograph.
All right, we're here with Nick Siegler in this very fun-looking lab. Nick, can you tell us a little bit about where we are?
Mike, we're in JPL's Starshade lab.
What exactly is a starshade used for?
Mike, there are 2 techniques that NASA is advancing to look for life on exoplanets. The starshade basically is a large shade that is flown outside of a telescope with the intention of blocking the light of the star. So then we can see the planet's light skirt the shade and captured by the telescope.
Okay, so this is much like I'm looking up at the sun and I want to see a bird or an airplane. I put my hand up to block the sun's light, but we have to do it on a much larger scale for a star.
The starshade itself is tens of meters in diameter. That's the size of a baseball diamond.
Just about how far away from the telescope would it have to fly?
It's tens of thousands of miles. You can fit like 4 Earths between the telescope and the shade. It's got its own propulsion system. It's literally its own spacecraft.
How do we get it up into space?
That's the engineering challenge, is how do we get something that has to deploy to tens of meters in diameter that could sit on top of a rocket? So now our engineers have come up with a technique based on the ancient practices of origami.
Sounds difficult. How do you know that's going to work?
Well, we do what we always do. We start small and we work our way up. So we started in this case with something just a few inches in size. Then we built something 1 meter in diameter, and we matured up to 2 meters. And now we finally got up to 5 meters. The one that flies in space is going to be tens of meters.
Okay, so you're using origami to make this really large star shade. It's a fun mechanical engineering project. But you mentioned that NASA is actually investing in 2 different technologies. What's the second technology?
That one is called the coronagraph.
The coronagraph. Can we take a look at that one?
Let's go.
Okay, Nick, this is obviously a lot different than the last lab we were in. We're in bunny suits now, we're trying to be super clean. Can you tell us where we are right now?
Mike, we are in JPL's high contrast imaging testbed lab. This is where we test the next generation space coronagraphs. Behind us is one of our vacuum chambers where we simulate the environment of space.
What's the big difference in approaches here?
With the starshade, we saw that the blocker was way outside of the telescope. Now, as another approach, we're going to take that huge blocker and shrink it down to the size of something that could fit in between your fingers. This way, it can fit on the back end of a telescope. This particular mask is the size of a pinhead. All of that starlight has to be focused right onto that little pinhead. We want to make sure that the focused light from the star hits the sweet spot of the mask. So it's critical that we have a mechanism to control the focused light.
All right, we saw the star shade and now the coronagraph. They're both crazy in their own ways, and it's a lot of really great engineering. So what's the end game? What do we hope to accomplish?
Mike, we're trying to develop the technology to be able to look for life on other planets. The hard part is blocking the light from the star. Once we do that, we have other technologies that are much more mature and will be in a better position to look for evidence of life.
Hi, I'm Brooklyn, and my question is, what is the closest exoplanet to Earth?
Well, the closest exoplanet to Earth, believe it or not, was just recently discovered this summer. It happens to be around our closest star, Proxima Centauri. It's about 4 light years away, and we had always wished that our nearest stellar neighbor would have planets, and we just confirmed that. Now, don't be packing your bags anytime soon. With our current technology, it's going to take probably about 80,000 years to get there. That's how distant the stars are from each other. But it bodes really well that maybe one day we will develop the technologies to actually fly there and take a look for ourselves.
Hi, my name is Brandon and I go to Sago Elementary School in Sago, Idaho, and my question is, what substances are exoplanet made of?
Exoplanets are made of many different substances. When you consider the planets in our own solar system, we see things like rock and lots of gas, and it turns out that exoplanets are also made of these same substances. But some of them are in different amounts. So for example, some planets have so much carbon, we consider them even something like a diamond planet. It turns out that there's a big range of exoplanets, ranging in size and in distance from their star and in temperature, and in the different amounts of gas that they have in their atmosphere. And every time we find a new planet, there's something surprising about it.
My name is Evan. My question is, how many telescopes for looking at exoplanets are there?
There are many telescopes looking for exoplanets. The 5 biggest telescopes on Earth, all over the Earth, including Hawaii and in Chile and many other locations, are all looking for exoplanets. But it's not just the biggest telescopes. Also, many of the smaller telescopes are working around the clock to keep searching for exoplanets using many different techniques. And it's not just on the ground. Many space telescopes are also looking for exoplanets, such as the Hubble Space Telescope and the Kepler Space Telescope. So many telescopes are dedicating a lot of efforts to try and find more of these exoplanets.
Hi, my name is Bodhi, and my question is, will we send a rocket to an exoplanet?
The nearest exoplanet to Earth is Proxima Centauri b. It's around the nearest star to our solar system. It's only 4 light years away, which is pretty close. But with the current rockets that we have, it would take about 80,000 years to reach that planet. So currently, we probably will not send a rocket there, but we are working on increased technology and better spacecrafts, which might help us get there a little bit faster.
One of the oldest exoplanets that's been discovered is PSR B1620-26b. This exoplanet is almost 13 billion years old and has been nicknamed the Methuselah planet.
Hi, my name is Haley. I go to Sago Elementary School in Sago, Idaho, and my question is it possible to have 2 Earths?
I'm feeling pretty optimistic that since we have one Earth that is flourishing with life, we don't see any reason why we can't find similar circumstances in our galaxy where there could be another planet that looks very similar to our own Earth, where life has taken hold, it's evolved, possessing a huge amount of diversity and maybe advancing intelligent life. So while we haven't yet discovered this Earth 2.0, if you will, we're very optimistic that over time we will.
My name is Krista, and my question is, do any exoplanets have rings?
Since exoplanets are so far away, it's very hard to detect something as faint as rings. However, if you look at our own solar system, several of the planets do have rings. So we do have reason to believe that there may be rings around other planets, around other stars. There's one example of a planet that was found to have a ring system so large, it's something like a super Saturn. It has rings that are 600 times larger than the rings around Saturn. So there are some planets around other stars with rings, but we'll keep looking for evidence of even more interesting and unusual planets with rings.
Hi, my name is Bill, and I go to Dalton Elementary, and my question is Pluto an exoplanet?
Well, Pluto has been the source of a lot of conversation. Pluto is a member of our own solar system. We refer to it as a dwarf planet. So it's not going to be an exoplanet because exo, by definition, means outside of our own solar system. But Pluto is special because it is a type of object that we expect to exist in all the other planetary systems. It's like a big dirty ice ball, if you will, a dirty snowball. And we think that Pluto is not alone, that there are tens of thousands of these snowballs that drift around in the outer part of our solar system. And the theory is that we should see Pluto-like objects around other stars as well.
Hi, my name is Nolan. I go to Siegler Elementary in Siegel, Idaho, and my question is it colder or warm on an exoplanet?
Exoplanets are actually, many of them are cold and many of them are warm. There's a huge range in the different temperatures and sizes of exoplanets. Some exoplanets are really small, similar to the size of Venus or even Mercury, and some are very large, even bigger than Jupiter. But also they are at different distances from their star. Some of them are much closer to their star than Mercury, and they would have an orbit of just about a few hours. Some of them are much further than Neptune, and their orbit around their star would take thousands of years. So given the huge differences in all the different types of planets that we find, some of them are quite cold and some of them are quite warm.
Exoplanets have pretty complicated names like 149026b. Just how do they name exoplanets? Let's find out in this NASA video short.
As you probably know, exoplanets can be pretty weird places. Some of them have atmospheres that are torch black or rain made out of molten glass. But do their names have to be so weird too? I mean, they have names like HD 20504b and Kepler 12c. Why can't they be named after cool stuff like Supreme Court justices or members of the Wu-Tang Clan? First of all, there are thousands of exoplanets, so coming up with good names for every single one of them would take a really long time. But more importantly, these names give astronomers really valuable information about each planet. And when you've got thousands of them to sort through, that's pretty helpful. A planet named like Ghostface would be cool, but it doesn't tell you a whole lot. One of the most common exoplanet names is the letters HD and then a whole string of numbers and then a lowercase letter. The HD and the number are actually the name of the star that the planet orbits. Astronomers have massive databases of stars and each one gets a number, so the HD part helps them look up the star's location. The letter at the end tells you in what order the planet was discovered, so the first one gets a B and then a C and then on down the alphabet. When a bunch of exoplanets orbiting the same star are discovered all at once, they'll usually be ordered based on their distance from that star, so the closest one will get a B and then the next one out C and so on. Now if later on astronomers find a new planet orbiting the same star, it will get the next unused letter, regardless of where it orbits. Now you might be wondering, why did the planet start with the letter B? That's because astronomers use a capital A to indicate the star in a solar system, or the brightest star if there's more than one. So in a binary system, the brighter star would get a capital A, the dimmer star would get a capital B, and the first planet would get a lowercase b. Sometimes stars with exoplanets will be named after the mission or the project that discovers them. So planets found by the Kepler mission will start with the word Kepler, and planets that were found by the Corot mission will start with the word Corot. There's been a lot of talk in the scientific community about trying to give exoplanets more interesting names, and it's likely that in the future some of the coolest discoveries, say if we find an exoplanet that we know to be a lot like Earth, those will finally get names that are easier to remember. That's it for this Q&Alien. Keep an eye on Planet Quest for the next video in this series and all the news and images you can handle, because exoplanet science never stops.
Hi, my name is Jackson, and my question is, how do telescopes work?
Telescopes are highly sophisticated optical instruments. You see them on the ground, on the tops of mountains, and we also fly these telescopes in space. And telescopes don't work that much differently than a pair of home binoculars. They have optics, and these optics allow us to capture images of stars and planets and galaxies that are very, very far away, and they help bring them closer to us and magnify them, so then we can study exactly the individual pieces and the parts of these planets and galaxies.
Samantha would like to know, what is the Goldilocks zone?
So the Goldilocks zone can be understood by remembering the fairy tale. So Goldilocks and the Three Bears, they discussed the porridge and said that it couldn't be too cold or too hot. They wanted it to be just right. And that's the right way to think about what the Goldilocks zone is in terms of exoplanets. So the Goldilocks zone is the distance from a star where we think that liquid water can exist in the liquid form. And this matters because we think that liquid water is necessary for life. If you think about our own solar system, Earth is the only planet, as far as we know, that has liquid water. And if you think about something like Venus, is too hot to have liquid water. So we want to keep searching for planets that are in that exact sort of distance from their star where they get just enough sunlight where they might be warm enough, but not too warm to maintain liquid water.
Hi, my name is Josie, and my question is, how are planets made?
Well, we've never actually seen a planet being made, but we have some pretty compelling theories. I'll share with you one of them. Let's take our favorite planet like the Earth, for example. Well, when the stars are brand new, just baby stars, they're surrounded by large disks of dust and gas. And this dust can be like sand grains at the beach. Well, given enough time, these sand grains and pebbles start to collide with one another, and over time they get bigger and bigger. I often like to think of planet formation sort of like the dust bunnies underneath my bed, that over time these dust starts to collect and they get bigger and bigger. What's interesting for a planet like our own Earth, that process of getting larger and larger stops at some point, and we're big enough to accumulate the gas, which thank God we're able to hold on to, because that becomes our atmosphere. There are some cases where the planets collect a lot of gas and they end up being Jupiter and Saturn, these huge, huge planets with a lot of gas. But they all start from very simple and humble beginnings, just collecting the grains of dust and gas around them and getting bigger over time.
We've seen at least 200 billion galaxies. Each galaxy is estimated to have billions, even trillions of stars. So astronomers think that there are about 10 to the 24th power planets in the universe. And that's just a guess.
Hi, my name is Asher, and my question is there gravity on exoplanets?
So each planet has its own mass, and mass is what generates the gravity. So the more mass that these exoplanets have, those perhaps that look like Jupiter are very massive, and of course those like our own Earth will be less massive. But in both cases, gravity is a fact of nature.
Yes, exoplanets have gravity. If a planet was about the same size as the Earth, it would have a similar gravity to what we feel here. If it was much smaller, it would feel like a much smaller gravitational force. But if it were something like Jupiter, or even larger like we see on some exoplanets, it would be very, very strong, and you wouldn't even be able to stand on the surface.
If someone wants to become an astrophysicist, what should he or she study in school?
Well, the foundations of astrophysics, otherwise referred to as astronomy, is the physics. So you have to commit yourself to taking the time and learning physics, and the language of physics is mathematics. Those two together create the foundation for being able then to do all of the exploration that we do. So I strongly encourage to dive into the math, dive into the physics, dive into the sciences that then help you understand the astronomy.
So if you want to become an astrophysicist, it's very important to focus on math in your early years. Math will, all of your math classes will contribute and help to your understanding of basically every science. Eventually you'll want to start to study some physics. Physics is the cornerstone of astronomy. We are really astrophysicists. And so studying math and physics is an absolute necessity. And I think you'll find that there's a lot of beauty and interesting things that you'll find in math that people get nervous that math will be scary or too hard, but it's a really wonderful and eye-opening field to study. Additionally, since astronomers now use so much data, and we work with images and data from telescopes, it's also important at a later point, maybe when you're in college, to do some programming or learn some computer science. This could give you an edge in astrophysics, but also in any other field. And it's really fun. It's nice to be able to work with images and try and find something new that no human has ever seen before. That's part of the excitement about astronomy.
And if Tiffany and I can become astrophysicists, I think anybody else can as well.
That's right.
I'm sorry, we've run out of time. My thanks to Tiffany and Nick for answering students' questions.
Thanks for having us.
It was a pleasure. Thanks.
My thanks to the folks at the Jet Propulsion Lab in Pasadena, California, and the folks here at the Faulkner Planetarium, at the Herritt Center for Arts and Sciences at the College of Southern Idaho in Twin Falls for hosting us. You can learn more about exoplanets and lots of other scientific topics on the Science Trek website. And we'll answer more questions about exoplanets on Science Trek, the web show. And if you want to submit a question for Science Trek, it's easy. You can send it as an email or a video question, recorded on your webcam or cell phone. And if you're an educator, we'll even lend you a camera. And each week, check out my blog for the latest science news for kids. You'll find all the details at idahoptv.org/science-trek. Thanks for joining us. We'll see you next time on Science Trek.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore and Bettis family legacy of building the great state of Idaho. By the Idaho National Laboratory, mentoring talent and finding solutions for energy and security challenges. By the Friends of Idaho Public Television, and by the Corporation for Public Broadcasting.
If you want to learn more about this topic or watch our videos, check out the Science Trek website at idahoptv.org/science-trek.